Have you ever looked up at a plane slicing through the clouds and just thought, how? How does something that massive, that complex, even get off the drawing board? Well, today, we're going to tear down and rebuild the entire process, deconstructing the world of the modern aircraft designer to see how it all comes together.
This quote right here just says it all, doesn't it? We're not just talking about a few more parts. We're talking about a level of complexity where the consequences of one tiny failure are, well, they're just unimaginable.
All right, so first, let's just try to wrap our heads around the sheer scale of this thing. This isn't just an engineering problem. It's a massive, interconnected puzzle with the highest stakes possible.
2 million. Just let that number sink in for a second. Over 2 million individual parts. And every single one, from a huge turbine blade all the way down to a single tiny rivet, has to be designed, tested, and integrated to work perfectly with everything else. Every single flight. To really put that in perspective, look at this. A car might have 10,000 parts. A plane, 2 million plus. Your car has maybe a mile of wiring. A modern airliner can have over 100 miles of it. And the regulatory paperwork? Forget about it. That's a whole different universe of complexity. So how do you even begin to tackle that kind of complexity? How does a spark of an idea, maybe even a sketch on a napkin, turn into a precise digital blueprint that you can actually manufacture? Let's walk through it. It's this really rigorous, step-by-step journey. It all kicks off with deep research, digging into new materials and aerodynamics. Then, those ideas start to take shape as conceptual sketches. After that, they're meticulously built piece by piece in 3D CAD software. And finally, they become these incredibly detailed engineering drawings. But here's the key. A drawing doesn't prove it'll fly. For that, you have to test it. And to do that testing, designers have an entire digital arsenal. You're talking about incredibly powerful software like CATIA and SolidWorks for the 3D modeling, ANSYS for running all the complex simulations, and MATLAB for crunching the data. Being a master of these tools, yeah, that's not optional. Now, obviously, you can't build thousands of multi-million-dollar prototypes just to see what works. It would be insanely slow and ridiculously expensive. So before a single piece of metal ever gets cut, how do engineers prove their designs can survive the brutal reality of flight?
Well, first, they stick the design into a virtual wind tunnel. It's called computational fluid dynamics, or CFD. This lets them simulate exactly how air is going to flow over every single surface, letting them tweak and optimize the design to squeeze out every last bit of efficiency.
Next up, they use something called finite element analysis, FEA, to digitally torture test every single component. Seriously, they throw massive forces at it, intense vibrations, extreme heat, all in the virtual world to make sure it can handle the absolute worst conditions. The whole point is to break it on a computer so it never ever breaks in real life. But even with these amazing digital tools, you run into a huge bottleneck. See, every design choice is a trade-off. A thicker wing is stronger, but a thinner one has less drag. The number of possible combinations is nearly infinite. Trying to test every single one manually, even in a simulation, it would take decades. And this is where AI just completely changes the game. AI-powered simulation can run through thousands, even millions of those design variations in a tiny fraction of the time. It can analyze all the trade-offs and even come up with solutions a human engineer might never have considered. But all these high-tech tools are only one piece of the puzzle. An aircraft is never designed by just one person. It's a massive, coordinated dance between dozens of different teams, and the designer has to be the choreographer of the whole thing.
The designer is basically the central hub in this super complex web. They're constantly talking with the analysis team, running the stress tests, with the manufacturing team to make sure the design can actually be built, with all the suppliers providing parts, and of course with regulatory agencies like the FAA who have the final say on safety.
And that's why a designer's day probably looks a lot different than you think. A lot of the time, less than half of their day is spent doing actual CAD work. The rest is just a whirlwind of meetings, documentation, and constant coordination to keep that whole network of people perfectly in sync.
So, as these game-changing technologies like AI get woven deeper and deeper into the workflow, the actual job description of an aircraft designer is being redesigned right before our eyes.
The designer of tomorrow, or really the designer of today, needs a hybrid skill set. That core knowledge of aerospace engineering is still the foundation, of course, but now it has to be paired with fluency in things like machine learning, data analytics, and just a relentless commitment to always be learning to keep up.
And here's the most crucial takeaway of all. AI isn't here to replace designers, it's a force multiplier. It's a powerful partner that can handle the insane amount of calculation and data, which frees up the human designer to focus on what humans do best: creativity, intuition, and asking the right questions.
Which leaves us with a pretty fascinating question for the future, right? As AI becomes more of a co-designer, taking on all that heavy analytical lifting, what are the uniquely human skills, things like creativity, critical thinking, ethical judgment, that will become the most valuable currency for the next generation of engineers designing the machines that will conquer our sky?